Welcome back, students. In this video, we're going to cover the Module 11 study guide. Let's see. There's going to be a few guys watching this school year's videos. This is an older study guide, so they're going to ask for lateral area. We only kind of touch on that. I'll get to that in a few minutes, but I just want to kind of give you a heads up. If you are going to try to work along, what I would suggest doing, have your reference sheet. If you don't have one, please see me. I will give you 3 copies if you'd like. I joked in class that I would like you guys to sleep with it under your pillow. Yeah, well, as we get closer to the test, I may not be joking. Sort of. Anyway. So, but I do want you guys to get familiar with that. I'm going to do a video on the reference sheet, but we're getting closer to time. I do have it on my other screen, but I don't know really how to make that happen and make it work. So I'll put the formulas up as we go, but do get a little bit familiar. Don't try to start finding stuff the day of the test. I do think you have plenty of time. Our test is between 45 and 55 questions, but still, just kind of get familiar with it. Plus, it'll help you as far as a study guide. It's, because if you don't know what the heck the formula is about, then come see me and, we'll do the best we can. Okay. All right, so number 1, what is the area of parallelogram? All right, so the area for the parallelogram is going to be, so used to, hold on, base area, but it's not base area. So the area, we would have been writing capital B for base area. So it's the same thing, but this is not the base of anything. It's just the area of this guy here. But it is base times height. So bases are both the same. The parallelogram means the opposite sides are congruent. So this would be your base. Now, this is the slant height. It's at a slant. This dotted line, we do this from the altitude, make it perpendicular so we have a right triangle. This 7 is telling us, so this bottom is one leg of our right triangle. This is across from the 90 degrees. The slant almost always will be, maybe always, but we'll say almost always just in case, because I'm that much of an overthinker. But this is our hypotenuse. So we're going to square that and subtract it from this squared to come up with our height squared. So let's see, so Pythagorean theorem. This will be c squared minus a squared. And we're just going to call it h squared because it's going to be our height up here. And it's going to be squared as we do this, so you'll have to get the square root. So 25 squared minus 7 squared is going to give us the height squared. And I'm just going to put height here. You're going to do the square root. We're going to look at the calculator. So 25 squared minus 7 squared. And I'm down here, you can't see, but it's the equals button. All right, so that's the height squared. I want the square root. So right beside the squared button is the square root. So, and you won't have to hit equals with this one. This is one of the few that you don't. So hit this. So your height is 24. Your height squared was 576. And if you square 24, that's what you get. And what we needed, that was the height squared. So we needed the square root, which was 24. So our height, I'm just going to equals 24. So back up here, base is 30, height is 24. 24 is already in there, so 24 times 30. And of course, we know that 30 times 24 is the same as 24 times 30 because of the commutative property. But either way, we get 720. This is centimeters squared. And if we look, this says 720. So B is our answer. All right, that's moving up. All All right, so a field is shaped like a trapezoid with the dimensions shown. What is the area of the field? So trapezoid, your area is 1/2 of base 1 plus base 2 times the height. Okay, so what's what? Glad you asked. So your bases here, when we're talking about a trapezoid, the bases are the parallel sides. And parallel lines, of course, would never touch. So pretend this is going on forever, this is going on forever. They would never touch. Does it matter which is base 1, base 2? Glad you asked that too. Let me show you. No, because, and we should know this, but this is 150 and 300. So I happen to know 150 and 300 is 450. I know 300 plus 150 is also 450. Just like 2 plus 1 and 1 plus 2. It's because of the, not commutative, that was the other guy. This is the, anyway. Distribute, no, not distribute. Dang it. See, I say this 10 times a day, man. This is so aggravating to mess it up on the video. I'll think of it in a minute. I'm thinking too hard. Anyway, we're going to rewrite this. A lot of you guys, we're multiplying this plus this times this, and we're getting half of it. You can multiply it by half. I like to just, we're going to put it all over 2. So base 1 and base 2, that's 300 plus 150. And then the height, so this is a slant, so that's not your height. This is your height. That's 1 times 150. So what you really have is 300 plus 150. That's 450 times 150. 67,500, and we want half of that. So it's 33,750. This is yards squared because it's area, and we're going to write it over here, 33,750. And this also is on the reference sheet. The only thing not on the reference sheet is the rhombus. We will talk about it. All right, I'm going to zoom out just a little to make this fit. It's a little bit larger. Oops, sorry. So, fill in the blanks using the available answer choices. So, regular polygon A, B, C, D, E. So, this guy in here, he's inscribed in circle G. So, G is the middle of the circle, so that's the name of the circle. Refer back to Module 10. I don't think we saw this in the notes this time, but, and it helps because they've made this a little easier, but they're asking us, so what is CD? So line CD, so as far as the circle, it touches both sides, but it's, CD is right here, so it's a side of that pentagon. Because A, B, C, D, E, that's 5. 5 is a pentagon of the pentagon. There you go. So it confirms that. Good for us. Now FG is the A or and blank of the pentagon. So FG is this guy here. So they put it in the circle because the pentagon without the circle wouldn't have this to show you. But anyway, so from the middle of the circle to the side of the polygon, that is called the apothem. Which is this word, which we're going to write here, but I like to just write it beside it because, you know, why not? You don't have to, but I did. Now, so I say that. So notice from the, what do we call something from the middle of the circle that touches the edge? That's a radius. So notice the radius goes from the center to the edge of the circle. The apothem goes from the center to the edge of the polygon right here, or the side of the polygon. So that's kind of why they do that, to bring that to your attention. Because when we do area of polygon, so I'll just write it over here. And this is on the reference sheet, but it doesn't hurt you guys. Area is going to be 1/2 of the apothem times the perimeter. And also on the reference sheet, little a apothem, big P perimeter. want to draw your attention also. So here, A apothem, that's just a number they're going to give you, just like R is radius. It's lowercase. Uppercase A, that's area, so you're multiplying some stuff. So uppercase means you're going to have to do some math. Sometimes you have to do math to get the lowercase as well, but that's because it's they're teaching you something else, you know, how to find the side or whatever. All right, number 4, the shaded area. You can see it a little better. I had to color it in at school. So what's the area of the shaded region? So we're going to find the total, which is the parallelogram. We know that because opposite sides are parallel. Opposite sides are congruent. They just gave us the actual height over here, so they cut us some slack instead of making us look at the slant height. So let me see. Hold on. Okay, so total minus. And technically this is a kite. We're going to call it a rhombus because they cut the kite out of the curriculum, but the rhombus has the same formula. And so we're going to take the total area of which is the parallelogram, subtract it from the rhombus, and that'll give us the shaded region. So, parallelogram. I'll just do that. Parallelogram is, hold on. I'll put my notes over real quick. Yeah, base times height. I thought so, but so this is your base. This is your height. 13 times 12. 13 times 12. All right, so 156 is the area of the whole thing, the parallelogram. And that's centimeters squared. All right. So I'm just going to write this over here, 156 minus, so now the rhombus. This is the only one not on the reference sheet. So the area for this guy is 1/2 of diagonal 1 times diagonal 2. I know it's hard to tell that that's a 1. So hopefully you guys get it. Now, that's the whole thing. This shows that these are congruent. This 5 goes with this part, so this 5. So one of your diagonals, I'm going to go back to and we're going to go D1, D2 over 2. Now we know D1 is 5 plus 5, so it's 10. And then this, so this means these two are congruent. This is 10, so this is 10. So diagonal 2 is 10 plus 10, or 20. All right, so 10 times 20 is 200. Divided by 2 means that the area of the rhombus, not a kite, is 100 centimeters squared. So 156 minus 100 is 56, and that's centimeters squared. All right, flip it over. We may end up doing this in 2 parts. We're going to see how it goes. I'm trying to get as much finished as I can, but not go too fast for you guys. All right, so number 5. Radar scope displays circular region with control tower at the center. Okay. If the maximum distance displayed on the scope is 6.3 miles, so this being a radar, this is from the center to the end, is 6.3. So it's not all the way across. This is the radius. So radius is 6.3. Always put your stuff over here on your scratch paper or on your actual sheet if you're doing like this. What is the area of the region displayed by the radar scope to the nearest 10th of a square mile? So this was a mile. So area of a circle, also on the reference sheet, is pi r squared. We use it a ton. You guys seen my tattoos? That may be my next tattoo before I change into middle school math. But anyway, so we know pi. The radius here is 6.3, and we're going to square it. So trying to get you guys in the habit of putting things in pi form. We're going to show that before we show the true area. So 6.3, and we're going to square it. So that's 39.69 pi. So if it asks for it in terms of pi, you'd give that. But we want times pi. Now, this is pi, 3.1419265.4. You got to hit equals. Beep. So equals. All right, so we got 124.68. They said nearest tenth, so we're going to round that to 7. So it'd be 124.7 square miles. All right, moving up. Number 6. All right, so the circle has an area of 12 square meters. I'm just going to write over here that a circle's area is pi r squared. All right, so it wants to know the area of the arc if the arc measure is 80 degrees. So to get the arc area, we'll just write it out. Arc area is going to equal the area of the circle, so pi r squared, times whatever the sector measure is. So in this case it's 80 degrees over 360. So now you're like, well, where's the radius? Well, we have the area. So in this case it's 45 times 80 divided by 360. So first off, why 360? Well, because a circle is 360 degrees. And then we're just the portion. This is 80 degrees. So that's how much of it. So that's how and then we know, because we know the whole area is 45. So 80 divided by 360. So that's 0.22222 of that whole pie pizza. Fat guy always talking about food. But multiplying that number times 45. So your arc, I'm just going to do this. Arc is 10. And that was meter squared. So we put that over there. All right, flip it over. Let me see. Yeah, I think we're gonna see. This is page. Yeah, I'm gonna stop at this. This will be part 1, video part 1. So I'll try to get it done, but the rest done tonight. But we'll see what happens. So number 7. So on page 4. So lateral area of the triangular prism is blank square inches, and the surface area is blank. So lateral area. So lateral area is what you see. So this is a triangular prism. So base is a triangle. Okay, so that means that this part and then the back side here, that's the top and the bottom. So top, bottom. So we're either looking at his face or his rear end. Anyway, so it would be setting up straight. So this, and this, the 3 rectangles that make up the prism would be the lateral area. That's what you can see. Because if you're standing up, I can't, unless I'm taller than you, I can't see the top of your head and I can't see the bottom of your feet. Just kind of think of it that way. So, but we're looking for surface area. So surface area of a prism is 2 times the base area, so the top and bottom, plus the lateral area, which is the perimeter times the height. We used to kind of teach this together. They separated it, but this right here, so lateral area equals perimeter times the height. So perimeter is going to be side plus side plus side. It's the walking around the triangle. So we're going to have to find the perimeter, which is in this case, so if this is 12, this is 12. If this is 10, so is this. We need this side, so we need Pythagorean theorem to find the third side, and then it's going to be 10 plus 8 plus whatever this is for the perimeter, because it's the three sides. We also need the base area, which for a triangle is 1/2 of base times height. This is the base. We need this for this too. So we're going to do Pythagorean theorem first. So this is across from the 90, so we have the hypotenuse, so we're going to be subtracting this from this to find this. So it's c squared minus a squared. It's going to equal, and we're going to call it h squared because it's our height. And remember, we'll have to unsquare it to make this number, to make this number, to fill out all that. Now the height for the actual prism is here, because remember, if this is the top and bottom, you flip it here, this is how tall it is. So we can fill in that number. That number is 12. We can also put the 2 times whatever the base area here is plus the perimeter. So hopefully we can fit all that in. I'll write it in red. So 10 squared, which is 100, minus 8 squared, which is 64. Leave the space. It's 8 squared. And that's 36. So our height squared is 36. Take the square root. Take the square root. Just to show you. And I'll do the whole thing. So 10 squared minus 8 squared. So it equals 36. Square root of that is 6. So our height is 6. So over here, this is 6. The base for our base area is 8. All right, so 8 times 6 is 48. We're going to divide it by 2 because we had to multiply, half of that. So the base area is 24. So now we can plug that in. We also know the height was our third side, so we can plug that in. It was 6. So our perimeter is 10 plus 8 plus 6, which is 24. So we can plug that in. So both just ended up being 24. That, don't let that throw you off. It's just a coincidence. So 12 times 24 is 288. So the lateral area, the perimeter, walking around it, times the height, so just that part, is 288. All right, 2 times 24 is 48. That is your 2 times the base, and you add them together. Oh, yeah, so 288. If you add 48, you're going to get 336, which is going to be the surface area, and that's inches squared. Oops. Okay. Hopefully you guys followed that. Let me know if you have any questions. All right, number 8. And this will finish off part 1. All right, so square pyramid. So the base is a square. It has a slant height, so that's that cursive L, of 7. That's this guy. Find the lateral area. So we know that's going to be the triangles of this pyramid, because the base is the bottom, the square. And the surface area. So for a pyramid, surface area equals base area. So one base instead of 2, because the prism had a base at the top of the bottom. The pyramid is a point, and then or a vertex, and the other end is the base. So only one base, plus, so we need the perimeter times the slant height. All right, so we do have one of those numbers. That is the slant height. That is the 7. Now, so this is a square. A square, the perimeter, because remember, a square is all 4 sides are equal. So this is 8, 8, 8, 8. Perimeter is 4 times the side, which is 4 times 8. So the perimeter is 32. We can plug in 32. We're going to write plus. All right, so, and the area, base area for a square is side squared or side times side, because the sides are equal. So you don't have to go base times height. So in this case, that's 8 squared, and 8 squared is 64. So 64. All right, so our lateral area is our perimeter times our slant height. Nope, 1/2. Excuse me. Well, I had to check the I'm glad I checked my formula. Whew, sorry. So 1/2. Let me just 1/2 perimeter times. So perimeter slant height half. So 32 times 7 is 224. Divided by 2, it is 112. Now, we'd been getting the right answer. I just wrote it wrong there, so not to make anybody worry. So your lateral area is 112, and then you're going to add 64 to it. That's the base, and your total is 176. So lateral area was 112 centimeters squared. Surface area was 176. All right, that's it for this half. I will finish the other half, either post it later tonight or tomorrow. If you have any questions, let me know via Focus Teams. If you haven't subscribed yet, I know it's close to the end of the year, please subscribe. You'll get the alerts. I'm going to post a few more videos for our EOC. Thank you guys for watching again, and have a good night.